Use Stoke's theorem to find the circulation of the vector field f around any smooth, simple closed curve C, where we're given the vector field f equals the gradient of the function f of x comma y comma z equals 5xy squared z minus 7 sine x squared z plus 2. For a quick review, the idea of Stoke's theorem is similar to Green's theorem shown here, where Green's theorem tells us the net rotation along the curve C is equal to the net rotation in the two-dimensional region R. However, in Stoke's theorem, the two-dimensional region R becomes a three-dimensional surface in space. Under proper conditions, Stoke's theorem shown here states the relationship between line integrals and surface integrals of a vector field. It tells us the net rotation over the surface S is equal to the net rotation on the boundary C. To use Stoke's theorem to find the circulation, we want to evaluate the line integral along the closed curve C of f dot dr. But if we recall from the fundamental theorem of line integrals, if the vector field f is conservative, then the line integral between any 2 points is a difference in the values of the potential function f at these points regardless of the path used. So again, because we're given the vector field f equals the gradient of the function f, we know the function f is the potential function of the vector field. And because we have a smooth, simple closed curve, if we start at one point and trace out the curve, we will end at the same point. So for the curve C, the beginning and ending points would be the same point if we consider the point x1, y1, z1 using the fundamental theorem of line integrals and the potential function. The line integral along the curve C of f dot dr equals the difference of the two function values, but notice here, again, because the curve is smooth, simple, and closed, the two function values are the same, and the result will always be 0. And we talked about this earlier. For any conservative vector field, if the curve C is smooth, simple, and closed, the line integral along the curve C of f dot dr will always be 0. So to answer the question, the circulation of the vector field around any smooth, simple, closed curve C is 0. I hope you found this helpful.